I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have a lesson with the student Rohan, who is trying to understand how do we prove the trigonometric identities. We'll begin with simplifying the trigonometric expressions using the strategies of factoring and rationalization. And then we'll take up some test questions based on trigonometric identities. You will understand many strategies as we go through this lesson today. Our approach, engaging minds, really help you to bridge the gap and apply the concepts learned. See how, in steps, we'll develop the strategies and apply them in proving the identities. In case you want to learn from me, you can always send an email on the address given. Gain confidence and get ready for the future. Let's begin with the class now with Rohan. Hi Rohan, how are you doing?
I'm good, sir. How are you?
Very good, very good. So in the last class, we talked about trigonometry and we picked on basics about trigonometric identities. Did you understand all that?
Yes, sir. I was able to understand what trigonometric identities were and how there's various different formulas, like for even and odd function and co-function identities, just to name a few.
Perfect. Yeah, those are great identities. So today we'll look into how do we solve problems related to trigonometric identities. So what I will do here is that we'll begin with, when you have to prove an identity, then basically it is an equation which is valid for all the values of unknown or the variable in its own domain. So we normally begin with one side, let us say left side, and we show that left side is equal to right hand side. You could begin with left side or right hand side. It really depends on which is more complicated. So pick up the side which is more complicated so that it can be simplified and shown equivalent to the other side. Is that clear to you?
Yes, sir.
So basically it means you have to simplify an expression which is on each side of the equation. So we'll begin with understanding how do we simplify an expression in general, right? So these few expressions which we are going to take, let us say 6 of them, in that case they will help you to prove many identities related to those kinds of expressions. Let me share with you the questions which I have prepared for you. Can you see my screen?
It's just shown up, sir.
Yeah, great. So first type of question which we are looking into is simplify each of the following expression with the techniques specified. So we'll actually develop our techniques as we move along. Okay. Let's say the first question there for you is simplify each of the following expressions. First is 1 plus tan theta over 1 plus cot theta. How will you simplify this expression?
So it's 1 plus tan theta over 1 plus cotangent theta, right, sir?
Yes.
So if it's that, then wouldn't we just what do you call it?
So tan theta
multiply
can
by
be
both sides?
Yeah, we could do that. So tan theta can be written as the ratio of sine theta over cos theta, correct?
Yes, sir.
And cot theta is reciprocal of tan theta, correct? It's basically cos theta over sine theta. These are the quotient identities which we learned, right? These are called quotient identities. Now, whenever you have some expressions, it is a good practice to write all the terms in sine and cosine to begin with. In that case, it becomes easier for us to work with. Is it okay? So let's rewrite the expression 1 plus tan theta as ratio of sine and cosine. So I could write this as 1 plus tan theta can be written as sine theta over cos theta. And 1 plus cot theta, it can be written as 1 plus cos theta over sine theta. Now, taking cos theta as a common denominator, you get in the numerator, you get cos theta plus sine theta, correct? Divided by, in the denominator, taking sine theta as the common denominator, we get sine theta plus cos theta. As you can see, sine theta plus cos theta can be cancelled from numerator and denominator, correct? Let me rewrite this. Let me rewrite this in a different ink. So it could be written as cos theta plus sine theta divided by cos theta times reciprocal of this, right? Sine theta over sine theta plus cos theta, correct? So clearly, you can cancel sine theta plus cos theta. What are you left with? You're left with the ratio sine theta over cos theta, right?
Yes, sir.
Which is tan theta. So we have simplified this expression 1 plus tan theta divided by 1 plus cot theta. It is equal to only tan theta. You get the idea?
Yes, sir.
Okay. There could be different ways of doing it. As you were trying to say in the beginning, I could have written cot as 1 over tan, right? Correct. I could have written cot as 1 over tan theta, right? So let's do, this was our first strategy. So strategy first was to write tan and cot using quotient identities as sine and cosine ratios, correct?
Yes, sir.
Now let me use a second strategy to do the same thing. Second strategy will be cot theta could be written as, let me rewrite here. Cot theta is 1 over tan theta, correct? So I could write cot theta as 1 over tan theta. So I'll use method 2 now, right? So we'll use the very first question and we'll use different method. So let me go to a fresh, okay, let me do it here itself. We'll do it here, right? So we'll again looking into this 1 plus tan theta over 1 plus, now cot theta can be written as reciprocal of tan theta, correct? So I could write this as 1 over tan theta. Does it make sense to you? Because cot theta is reciprocal of tan theta.
Wait, sir, is this for like the first question, like another method?
Yeah. I'm using second.
Oh.
Yeah, second method, method 2. This is method 1. So that gives you flexibility, you know. So now I will write this as 1 plus tan theta. And here I can write tan theta plus 1 over tan theta. And so this could be written as 1 plus tan theta times tan theta over tan theta plus 1, correct? Now I can cancel these and get my result, which is equal to tan theta. Do you see that?
Yes, sir.
So within much lesser steps, without even getting into the quotient identities, I could actually simplify this expression as equivalent to tan theta. Perfect. It is good to use different methods so that, you know, when need be, you could use, you know, your strategies learned.
Sorry, sir, I'm just coughing.
No problems. Your copy. Once you're done, let me know.
I'm done, sir.
Very good. Did you appreciate these two methods of doing it?
Yes, sir. I found the second method like way more easier.
Yeah, yeah.
And it's like less steps, but it's also more
Correct.
neater and easy to understand.
Correct. So now let's do question number 2, right? So when I have this expression, 1 plus, now we are doing question number 2, which is 1 plus sine square x divided by 1 minus sine to the power of 4x. How do we simplify this? Now, to give you a hint, you remember what is a square minus b square equals to?
Would it be a square plus
a
2?
plus b, a plus b times a minus b. Difference of squares is product of sum and difference. A square minus b square is a plus b times a minus b, correct? So we can see the numerator is 1 plus sine square x. The denominator is 1 minus sine to the power of 4. You get the idea. So we could write this as what? The numerator as 1 plus sine square x, and using this concept, the identity, algebraic identity, a square minus b square is a plus b times a minus b. I could write 1 minus sine to the power of 4 x as what? I could write this as 1 plus sine square x times 1 minus sine square x. Does it make sense? 1 plus sine square x times 1 minus sine square x. So that gives you 1 square minus sine square x whole square, which is sine to the power of 4x, correct?
Yes, sir.
And simple, you can cancel this, and what are you left with? You're left with 1 over
1 over
1 minus sine square x. Do you remember what is 1 minus sine square x? We did Pythagorean trigonometric identity, which was sine square x plus cos square x is 1, correct?
Yes, sir.
So from here, you can write cos square x as equal to 1 minus sine square x. So sine square x can be written as cos square x, right? So now I can simplify it further and write this as 1 over cos square x, correct?
Yeah.
Now what is reciprocal of cos? 1 over cos x is secant x, right? So I
Yeah,
can write this as secant square x. You get the idea? So we have simplified this term to secant square x, correct? Do you see how we did it? So many
yes, sir.
concepts you have learned here. You have seen how the algebraic identity a square minus b square equals to a plus b times a minus b can be utilized in solving or simplifying trigonometric expressions. Okay, so let me clear the screen, and then we will. So first expression, we proved this equals to tan theta, correct? And the second one,
Secant square theta.
secant square x in this case. Is that clear to you?
Yes,
So
sir.
that, if I would have given you a question like this, then we are trying to prove an identity. Get it? Okay. So that is first two questions. Now let's look into more questions now. Slowly. Here are another two questions. Perfect. Question number 3 and 4. We need to simplify 1 over 1 minus sine x plus 1 over 1 plus sine x. How will you do it? Can you suggest?
So it's 1 over 1 minus sine x and plus 1 over 1 plus sine x.
Yes.
So if we're doing that, sir, why don't we make it as 1 plus sine of x?
We take
Like
a common
basically
denominator.
like the a minus b whole square.
Yeah. We can take a common denominator, right? So the common denominator, just when you add fractions, right? The concept is common denominator. So the common denominator will be 1 minus sine x times 1 plus sine x, correct?
Yes, sir.
And then it gets cross multiplied. You get 1 plus sine x plus 1 minus sine x, correct? Now the numerator is 1 plus sine x plus 1 minus sine x. So sine x minus sine x is 0. you get 2 in the numerator. In the denominator, I have 1 minus sine x times 1 plus sine x, which is 1 minus sine square x. And that means that 1
Wouldn't
minus
it
sine
be
square x is cos square x,
2
right?
over cos x or 2 secant square x?
Correct. 2 secant square x. Do you see that? So this expression is twice the previous expression. You get the idea?
Yes, sir.
I could have given you an identity equating both, which would be a difficult identity. You get the idea? And
Yeah.
both will be equal to, I mean, that one was secant square x. This is twice secant square x. Perfectly fine. So you see how we simplified one side and then we kind of get an identity. And you're getting now the flavor of this, right? Question number 4 now, we have to simplify an expression which looks like something like this. Square root of 1 plus cos x over 1 minus cos x. How will you simplify this particular expression? Question number 4. Can you suggest, please?
The equation is 1 plus cos x over 1 minus cos of x, sir.
Yes.
So if we're doing it right, sir, why don't we multiply both of the square roots? So it would just be like square root of 1 plus cos of x over 1 minus cos of x.
Okay, so what we will do here is we'll do rationalization. So the concept here is we do rationalization. Normally, we rationalize denominator. Rationalization basically means multiply by the conjugate. Then we use the concept a plus b times a minus b is a square minus b square. So what we'll do here is that we'll multiply and divide by 1 plus cos x square root. 1 plus cos x. Multiplying and dividing by the same term means multiplying by 1. It doesn't really make a difference, correct?
Yes, sir.
So now, when I multiply this, 1 plus cos x square root times 1 plus cos x square root is square of this. I could have written numerator as 1 plus cos x, correct? And the denominator, 1 minus cos x times 1 plus cos x is what? Within the square root, I get a square minus b square, right? I'm writing here, I'll do it in 2 steps. 1 minus cos x times 1 plus cos x, correct? So let's rewrite. So in the numerator, I have 1 plus cos x, and in the denominator, square root, and within square root, I have 1 minus cos x times 1 plus cos x, which is 1 minus cos square x. One minus cos square x is sine square x. And square root of sine square x will be sine x. So I could simplify this particular expression as 1 plus cos x over sine x. Do you see that?
Yes, sir.
So that is how we could work with the trigonometric expressions, simplify them. This time we use the strategy of rationalizing the denominator. So solution of question number 3 and 4 is clear to you?
Yes, sir. I just had a quick question. So you know how for the 1 plus cos x over like divided by square root of 1 minus cos square x, right, sir? Did we use the absolute value function to get 1 plus cos x over square root sine square x?
Actually, what you're saying is a very, very valid point. So whenever you have a square root function, we always get a positive value, correct? And in the first case, when we multiply, that's fine. But now we are doing square root of sine square x. We get absolute value of sine x. You see that? So
Yes, sir.
actually, the function is always going to be positive, right?
Yeah.
And here also we have 1 plus cos x whole square, and this is also an absolute value. So strictly speaking, I should have written here absolute value of 1 plus cos x, right?
Okay.
So the question, solution will be like this. You get the idea?
Yes, sir.
Yeah. Normally, I take it at a later stage, just an introduction. I didn't want to do it that complicated, but you understand it. So that's very beautiful. So what you really understand here is that what is square root of x squared?
It can be plus minus x,
Or
but in
absolute.
order to do, we have to make it absolute.
Yes. So square root of x squared is the absolute value of x, and therefore, in both these cases, we had 1 plus cos x whole square, and here we have sine square x, right? Within the square root. And therefore, when you remove the square root, you will get absolute value of inside. Correct? Perfect?
Yes, sir.
So that is the right answer. So I could write this as an identity. So let me clear this. The first one, we showed equals to 2 secant square x, correct? And the second one was absolute value of
Plus cos of x over sine x.
Correct. So that becomes a trigonometric identity. And if you are given this identity, you'll begin with the left-hand side, simplify the expression just as we did, right?
Yes, sir.
Do you understand how simply by simplifying one side, we get the other side? And this could be a question on identity also, as shown here, right?
Yeah.
Very good. I really appreciate this part, which you pointed out. Square root of x squared is equal to absolute value of x, and therefore we have this absolute sign. This term is always positive, right? So that is to be noted. Clear. So let me move on to the next page, next set of question, and now we are looking into identities as such. So what we did was that we actually learned how do we simplify one side to get the other side, right? Now in
Yes,
this
sir.
question number 5, it's an identity. You need to prove this identity. 1 minus cos theta over sine theta equals to sine theta over 1 plus cos theta. How will you do it? Tell me.
So 1 minus cos theta over sine theta is equal to sine theta over 1 plus cos theta.
Yeah.
So I would say that the best way that we can do it is start from the left-hand side.
Okay.
And solve it.
Left-hand side. So left-hand side is given to us as 1 minus cos theta over sine theta. We need to simplify this and get the right-hand side. So how will you do this? So how will you simplify this now?
So if it's 1 minus cos theta over sine theta, right, sir?
Yes.
It can be 1 minus cos theta, and then we do sine theta.
We can multiply and divide by the conjugate of 1 minus cos theta. Now we can rationalize the numerator. Last time we did denominator. You get the idea? So multiply and divide by 1 plus cos theta. Do you understand? That is the strategy we learned in simplification. We are going to apply the same strategy now, this time to the numerator, rationalizing the numerator. Is it okay? Perfect. So now the numerator is 1 minus cos theta times 1 plus cos theta, which is 1 minus cos square theta. And the denominator is product of sine theta with sine theta with 1 plus cos theta. Look here. If you look at the right-hand side, you will notice that we already have 1 plus cos theta in the denominator, right?
Yes,
What
sir.
is 1 minus cos square theta?
Wouldn't it be sine? Oh, wait. 1 minus cos squared theta would be sine squared theta.
Correct. And we have sine theta times 1 plus cos theta. Now what? Sine square theta divided by sine theta. One of them will get cancelled. You're left with sine theta in the numerator, right? And the denominator is 1 plus cos theta, which is the right-hand side. So we have shown that the left-hand side is equal to right-hand side, and that is how you prove the identity. Is that clear to you?
Yes, sir.
So we have used the concept a plus b times a minus b is a squared minus b squared. You now know the rationalization of numerator, simplified the terms, and got the identity proven. Perfect. Right, so let's move on, take the next example. So Rohan, are you ready?
Yes, sir.
Okay. So let me clear all this and go to the next example. Now this is slightly more complicated. We have question number 6 here. Can you please read the question?
So sine to the power of 6x plus cos to the power of 6x is equal to 1 minus 3e multiplied by sine squared x multiplied by cos squared x.
So how will you do this?
I would say that in order to solve this equation, we have to find out one of the sides to make sure the other side is equal. So I would say that it might be best if we do solve the right side. So 1 minus 3 multiplied by sine square x multiplied by cos squared x.
Okay, you could do that, but easier method actually is factoring. Let me review some factoring skills, which I think you may need it, right? You know what is a cube minus b cube equals to? A cube minus b cube, write on this formula. We are going to use one of these formulas. A minus b times a squared plus ab plus b squared. And a cube plus b cube is equal to a plus b times a squared minus ab plus b squared. Just as we have difference of squares, we use that formula, right? A square minus b square, you know that is a plus b times a minus b, right? Similarly, we have sum of cubes and difference of cubes formula as given here. We can use one of these formulas to write sine to the power of 6x plus cos to the power of 6x and simplify it in the factored form. So plus means this formula, correct?
Yeah.
So applying this formula, we can actually prove this identity. Does it make sense?
So we would plug in a cube plus b cube's formula into sine to the power of 6x plus cos to the power of 6x.
So we'll again begin with left-hand side, and we can write this as, so I want to make it a cube. So I'll write sine square x whole cube. Do you see that? Plus cos square x whole cube. So it becomes a cube plus b cube, right?
Yes, sir.
Using the formula, I could write this as a plus b. A is sine square x and b is cos square x. So which is sine square x plus cos square x times a square, which is sine to the power of 4 square x minus a times b, which is sine square x cos square x plus b square, which is cos to the power of 4x. Is that clear to you?
Sir, I understand the first half where it's sine square x plus cos square x. But when we get sine 4x minus sine to the power of 2x multiplied by cos squared x plus cos to the power of 4x,
Yeah.
how do we get that part? Is
Let me
it
show.
like
Let me
from
show.
expanding the formula?
Let's see. Let's look back. The formula AQ plus BQ is equal to A plus B times A square minus AB plus B square, correct?
Yes, sir.
What is A in this case?
Sine.
Sine square x. And what is B?
So then B would be cos squared x?
Right? Do you see how I've written? Sine square x cos square x cube, right?
Okay, sir. So basically what you're doing is you labeled which one would be A and B, and from there on you just put for A cube plus B cube, which is equal to A plus B multiplied by A squared minus AB plus B squared. All you just did was you inputted sine squared x plus cos squared x into one bracket, and then from there you did sine squared x to the power of 2 over to the power of 2, which is just the power of 4. So
Yes.
you basically multiplied where if for A square and B square, right, sir?
Yes.
To get that formula?
Yeah. So when there are
Oh.
higher powers, we do something like this. You see this strategy.
Yes, sir. Now I understand. Basically, you just expanded and also you labeled which one would be which.
Yes.
That's
Now, what is sine square x plus cos square x? Oh, let's go back. Sine square x plus cos square x is 1, right? Pythagorean identity. This is 1, correct? Now we have sine to the power of 4x minus sine square x cos square x plus cos to the power of 4x. You remember one more formula? What is a plus b whole square? Let me
A
write
plus
down.
B whole square. A square plus 2AB plus B square.
Yes. So that means that since we have two squares here, right? Sine to the power of 4x plus cos to like a square plus b square, right? So this implies that what is a square plus b square equals to? A plus b whole square minus 2ab, correct?
Yes, sir.
So I have sine to the power of 4x and I have cos to the power of 4x. Like I could write this as a square, a plus b. This is like a square, right?
Yeah.
A equals to sine square x and b equals to cos square x, correct? So I could write this as a plus b whole square, which is sine square x plus cos square x whole square minus 2 times ab sine square x cos square x. Is that clear to you? So the second factor, sine to the power of 4x minus sine square x cos square x plus cos to the power of 4x can be written as sine square x plus cos square x whole square minus 2 sine square x cos square x. You get the idea?
Yes, sir. I understand. So basically, now what you did is from A cube plus B cube, you used the formula of A squared plus B squared, where you just got A plus B whole squared minus 2AB, right, sir?
Yeah. Now, Sine square x plus cos square x is 1, and therefore this is already 1. 1 times anything is the same thing, right? So what we get here is sine square x plus cos square x whole square is 1 only. Oh, okay. I did not copy this part, which is minus sine square x. Let me rewrite. And so this is what I wrote for these two things. Cos to the power of 4x plus sine square, right? Now we already have minus sine square x cos square x already there, correct?
Yes.
Now let's combine. So sine square x plus cos square x is 1 minus 2 sine square x minus sine square x cos square x is 3 sine square x cos square x. Which is the same as right hand side.
So, sir, the final answer would be 1 minus 3 sine square x cos square x, right, sir?
Which is right hand side. So we have shown that left hand side equals to right hand side. So we have proven the identity. Correct? So we started with sine to the power of 6x plus cos to the power of 6x. And we have shown that is equal to 1 minus 3 sine square x cos square x. Perfect.
Okay, sir. Yes, sir.
So this was a complicated example based on trigonometric identities to start with. However, do you understand these steps?
Yes, sir. I was able to understand how when we started off, how we chose the side, how we labeled like which one would represent which, using a cube plus b cube to then transform it to a square plus b square, and then how we got our answer as the same as the right side.
Great. So many algebraic manipulations you should be good at to prove the identities, just as we have seen in this particular example. Perfect? Okay,
Yes, sir.
let's clear this and move on to the next page. Next set of questions. This is actually pretty complicated. This is 3 cos theta. Okay. So let's redo it. We will start with, so question number 7. Sine square theta plus 2 cos theta minus 1 divided by sine square theta plus 3 cos theta minus 3 equals to cos theta over cos theta minus 1. So that's a trigonometric identity, slightly complicated for you to prove. How will you do it? Tell me. You're on mute, so Rohan.
So it's the 7th question, right, sir?
Yeah.
So how are we supposed to solve for the left side?
Yeah.
Okay.
How will you?
So I say that for when we're doing sine square theta plus 2 cos square theta minus 1 over sine square theta plus 3 cos square theta minus 3, we can change it from sine theta to cos theta, where it would just be, instead of sine square theta, it would now become 1 minus cos square theta.
So let's do that. Well, write the left hand side as equals to 1 minus cos square theta for sine square theta, correct? Then we have plus 2 cos theta minus 1 divided by sine square theta. I'm again writing this as 1 minus cos square theta plus 3 cos theta minus 3. So we have turned each term as cosine function, right? Now it's easier to factor, correct? So then
yes.
1 minus cos square theta plus 2 cos theta minus 1. 1 minus 1 is 0. We are left with minus cos square theta plus 2 cos theta. Divide by 1 minus cos square theta, and here we have 3 cos theta minus 3. So you can actually group factor. Do you see that? So 1 minus cos square theta can be written as 1 plus cos theta times 1 minus cos theta. Plus, here we can factor 3. So we get cos theta minus 1. Is that clear?
Yes, sir.
Cos theta minus 1. Now in the numerator, I could factor, let's continue with factoring, cosine theta, right? So we have cos theta factored out. So we're left with minus cos theta plus 2. Now I have 1 minus cos theta and cos theta minus 1. Do you see that? So I could write 1 minus cos theta as negative of cos theta minus 1, right?
Yes, sir.
So I could factor 1 minus cos theta, getting 1 plus cos theta from the first term, and the second term minus 3. Because it is cos theta minus 1. You get the idea.
Yes, sir.
So now we have, in the numerator, we have cos theta times 2 minus cos theta. And here, we have 1 minus cos theta times 1 minus 3 is minus 2, right? So cos theta minus 2. Now, 2 minus cos theta and cos theta minus 2 with a negative sign, we could write this as what? As changes. So cos theta times 2 minus cos theta, I could write the denominator as negative of this, right? Which is, well, I want 2 minus cos theta. It is cos theta minus 2, right? So we write minus 1 minus cos theta times 2 minus cos theta. Now this 2 minus cos theta cancels, and we get the expression cos theta over minus of minus means minus 1 plus cos theta, which is cos theta minus 1, right? Which is same as right hand side. So did you see how we prove this identity?
Yes, sir.
So a lot of manipulation done here, and basically you have to work with the factoring skills to solve such a question. Perfect. Now, while you're doing such questions, it is important to understand that if you keep an eye on what is required, you wanted cos theta minus 1 in the denominator, right?
Yeah.
It was a good idea to factor out at this stage cos theta minus 1 rather than 1 minus cos theta. In that case, you will get the correct signs and you will get the right answer faster. Perfect.
Yes, sir.
So these are a few things which you have to keep in mind while proving the identities. Perfect.
Yes, sir.
So this is very important to understand. So I hope these steps are clear. We can take up another challenge questions. So here is another question. The question here is tan theta plus secant theta minus 1 over tan theta minus secant theta plus 1 equals to 1 plus sine theta over cosine theta. How will you do this?
So it's tan theta plus secant theta minus 1 over tan theta minus secant theta plus 1. That's equal to 1 plus sine theta over cos theta, right, sir?
Yeah.
So if let's assume that the right side would be the answer. So we could solve for the left side in order to get the right side.
Correct. Yes. So on the left-hand side, because we are given tan and secant, on the right-hand side, we have sine and cosine. The idea is to write tan and secant as sine and cosine, right? So let's begin with left-hand side. And tan theta can be written as sine theta over cos theta. Secant theta is 1 plus 1 over cos theta minus 1 over tan theta sine theta over cos theta minus 1 over cos theta plus 1, correct? And now you can multiply both numerator and denominator by cos theta, right? Get rid of denominator, get rid of fraction. That is the concept. So when I multiply and divide by cos theta, in the numerator, I'm left with sine theta plus 1 minus cos theta. Is that correct? And here I get sine theta minus 1 plus cos theta.
Yes, sir.
Okay. Now, how will you solve further to get 1 plus sine theta divided by cos theta on the right hand side?
So if it's sine theta plus 1 minus cos theta, right, sir?
Yeah.
Over sine theta minus 1 plus cos theta.
Mm-hmm.
Shouldn't we change the function to sine theta?
How will it be?
So if it's sine theta plus 1 minus cos theta, then it could be sine theta plus sine plus 1 plus sine squared theta.
So the Pythagorean identity is sine square theta plus cos square theta is 1, right?
Yes, sir.
So in this case, what will you do? We have sine theta minus cos theta. One could be written as, so it's a very tricky question. You know, we have sine theta minus cos theta. We have 1 here. We could write 1 as sine square theta plus cos square theta. We could write that. But will that help us?
No, sir.
Not much, right? And in the numerator, also we have minus 1. So how will you simplify it further? Now, let me give you an idea. When we did trigonometric identities, we also learned about Pythagorean trigonometric identity in tan, right? 1 plus tan square theta is what?
1 plus tan squared theta.
Is secant square theta, right? So from here, I could write 1 equals to secant square theta minus tan square theta.
Yes, sir.
And secant square theta minus tan square theta can be written as secant theta plus tan theta times secant theta minus tan theta. Is that clear to you?
Okay, sir. So we're using the Pythagorean, like the trig Pythagorean formula to, and then we're subbing in tan theta and secant theta, right, sir?
Correct. So if I do this substitution in the numerator, which is tan theta plus secant theta minus 1, in that case, you see, one could be written as this, and I am in a position to factor. You get the idea. And this can help us to simplify or prove the identity. Does make sense to you?
Yes, sir.
So slightly more complicated. Let me just clear this all and then again start with this kind of solution. So what we understand now is that we know that 1 plus tan square theta is equal to secant square theta. And this implies that 1 basically is secant square theta minus tan square theta, which can be written as secant theta plus tan theta times secant theta minus tan theta, correct? So we are going to change, let's say in the numerator, minus 1 as, so we have in the left-hand side, we have tan theta plus secant theta. Instead of minus 1, I'm writing secant theta plus tan theta, product of sum and difference. And in the denominator, we have tan theta minus secant theta plus 1. Do you see that? Now you can take secant theta plus tan theta common. And you're left with 1 minus secant theta minus tan theta, correct? Over tan theta minus secant theta plus 1. If you open that bracket, you get what? You get secant theta plus tan theta times, open this bracket, you get 1 minus secant theta plus tan theta, correct? Divide by tan theta minus secant theta plus 1, correct?
Yes, sir.
Now this term cancels. And you're left with secant theta plus tan theta. What is that? Secant is 1 over cos theta, tan is sine over cos theta, right? Cos theta is common denominator. And we get 1 plus sine theta in the numerator, which is right-hand side. So that is how we are going to solve this particular identity very efficiently. Otherwise, this is a very difficult question. So in this question, if you write down tan and secant in terms of sine and cosine, it would be a very lengthy solution. Here, we have a very good, easy solution. So this is actually one of the very difficult questions which you'll get in MCR3U, grade 11, trigonometric identities. And I've seen this question many times in the test papers.
Okay, sir.
Is this solution clear to you?
Yes, sir. I was able to understand it. So after when solving all of it, you got secant theta and theta, and then from there you changed secant theta and tan theta to their
Sine and
primary functions. So secant theta, which would be 1 over cos theta, and tan theta, which is made up of sin theta and cos theta.
Right.
And then from there, you just multiply. You just added them up, right, sir?
Yeah, common denominator is cos theta, so you get 1 plus sin theta in the numerator, which is the right-hand side, right?
Yes, sir.
Perfect. So with this, we'll end our class. I'd like you to actually go through these solutions, rather solve them yourself uh, after about an hour or so that you are, sure how do we solve such questions. Is that clear to you?
Yes, sir.
I'll upload the video. So when I upload the video, when you look at the question, pause the video and answer it yourself. That will help you.
Okay, sir.
Great. Okay, then we'll end the class here. All the best.
Okay, goodbye, sir.
Thank you. Bye.